Alright, in the last section we dealt with mainly square roots, and that was a getting ready for this chapter actually section. So we figured out by looking at sort of what square roots and squares were, that if we're talking about the square root of 169, that literally means what number do I have to multiply to itself, square, and get 169. So if that's true, then what do you think that this would be? Because no longer, whenever we just have a plain radical like this, we assume that there's like a little 2 inside there, and it's not written. But in this case, we have a 3 inside there. So if I go by this same exact idea here, if the square root means what do you square to get this number, then this is the cube root of 8 is how this is read. So that literally means what do we have to cube to get 8? Or what do we have to multiply to itself 3 times to get 8? Okay, this is what this entire section is going to be about. We're going to be talking about roots, and they call it nth roots, which means any root. It could be the second root, the third root, the fifth root, the 10th root. It doesn't matter. Any root. When they say nth, it means any. Let's first talk about some vocabulary because we're going to need that. Okay, this little number right in here, inside this little crook, notice that it's not on the outside as a multiplication. It lays right there in the crook of that symbol. This is called the index, and it tells you which root you're finding. So when we deal with a square root, like if we had the square root of 4, we don't have a number here as our index. It's an understood 2. But if we have a cube root, it has to be written, or if we had a 4th root or a 5th root or so on and so forth. So this number here inside this little crook is our index. The actual symbol itself is called the radical symbol. And the number that's underneath the radical is called the radicand. So we'll be talking about that off and on. And, I'll be saying things like, well, the radicand of 8, and I expect that you understand what that vocabulary then means. So pay a lot of attention to that. Now, just like we did with the squares, I would highly, highly suggest creating a list of perfect cubes. And the cubes get big really fast. So really the ones you have to know pretty much off the top of your head would be 1 through 5. So if you know that 1 cubed is 1, all the way up to 5 cubed is 125, you're going to be in pretty good shape. And then realize also that we can go backwards. So same idea as squares and square roots are opposites of each other. Cubes and cube roots are opposites of each other. So to go backwards, we would do the cube root of 1 is 1. The cube root of 8 would be 2. The cube root of 27 would be 3. And so on and so forth. Okay? Now there's just another couple of things that we need to talk about here. This is really important. Earlier in that previous section, we talked about things like the square root of -4. And we said the square root of -4 means what do you have to square to get -4. And there was nothing that we could square to get a -4. So we knew this was not a real number. But what about if we had a cube root of -8? Remember that the cube root of -8 literally means what do I have to cube in order to get a -8? And when we talk about raising things to odd powers, we can get negative numbers. In fact, this would be a -2, because -2 times -2 times -2, which is -2 cubed, is -8. So another thing that we have to be aware of and pay very close attention to, you can take the odd root of a negative number, but you cannot take the even root. So that's why we can do the cube root of a negative, because it's an odd root. We cannot take the even root of a negative number. That's why we couldn't do the square